So we started 11 years after the cloud with a clean sheet. We were going to break some rules because everybody else in the market, the other 3 or 4 hyperscalers, have got pretty much the same architecture, but we were able to be different. So 5 things we did that were quite different. First thing we did is, it's technical there, it says off-box virtualization, but basically we isolated the cloud provider's control plane from what the customers run. So there's a physical separation and isolation there. That's a good thing from a security perspective. Just in day one, security is built in. There's physical isolation between what we deploy to control the cloud versus what the customer brings on top of the cloud. That is very differentiated relative to the other cloud providers. It also means we take away the hypervisor tax, that performance overhead that a software-based hypervisor delivers for you, right? Because we're running off-box in its own processor adjacent to you, not underneath the customer tenancy. Very, very different. So with that difference, you get some performance benefits. We also then said, performance is good, but enterprise workloads needs predictability as well. So how do you get predictability? Well, everything in the cloud is deployed across the network. Everything's a network resource in the cloud. Well, in the other hyperscalers, you don't know if something's going to be 2 hops away, 5 hops away, or 17 hops away as you go between service 1, service 2, service 3. And as you go between region 1 and region 2, it's completely unpredictable. In fact, your early deployments may be 3 hops away, the next ones might be 5 hops away. So we redesigned the networking infrastructure in OCI, so everything was 2 hops away. That now delivers you predictability. So you got performance and isolation from the first differentiation. You got predictability with the second differentiation. Now, with that predictability and performance and isolation, we're the only hyperscale cloud that can deliver performance-based SLAs as well, not just availability SLAs. Availability SLAs, everybody does. Are you alive? Yes, I'm alive. Performance SLAs, are you alive and can you run 0 to 100 in 5 seconds? Yes, I can. There's a performance implication behind it. We can do that because we're isolated, there's no hypervisor and bare metal, we've got predictable networking infrastructure. We also then maximize how much we pack into the density. So we're running in green data centers, but within those green data centers, we're very, very highly dense, dense in our compute structures, so we take less floor space. So that in itself also delivers benefits for customers. Extremely flexible infrastructure. The cloud was all about elasticity. It was all about agility, right? Why do you go to cloud? Because you can provision things really quickly. You can start small, you can scale up fast, you can scale down fast. That was what cloud was supposed to be. But the other hyperscalers tend to put you into fixed t-shirt sizes of shapes. And we took all of those boundaries away because we started clean. So we don't have fixed t-shirt size for shapes. You design the shapes you want. Slider bar, how much of CPU, how much of memory, how much of storage IOs you need, and how much networking throughput you need. And all of that is completely configurable and flexible for our customers, not available anywhere else, right? So we're putting, or the way I like to say it, we're making the cloud elastic again, right? You can start really small, you can scale really, really quickly. And last but not least, simple, predictable pricing. Quite often when we speak and present quotes to customers, they ask us, have you made a mistake? Right? It doesn't seem right. And I think it's important, Ian, you asked for orders this afternoon. I'm just going to ask for quotes, right? Maybe we can ask for quotes this afternoon. But I think it does come across that, there's a significant difference. Why? How do we do this? It's because it's architected differently, right? So we can actually do this in a very, very different technology footprints.